All right, does anybody need to print this out? Did you print 1.2 out already? Go into D2L and print it out. And I could pause it. Okay, this is section 1.2, the basics of functions and their graphs. Okay, some more. So here's another math term. A relation is any set of ordered pairs. The set of all first components of the ordered pairs is called the domain of the relation. So the domain is the values x can take on, or the values x can be. The set of all second components of the ordered pairs is called the range of the relation. And that's about all the values that y can be. Okay, so we're going to find the domain and the range for each relation here. So any set of ordered pairs, x comma y, here's a set of ordered pairs. This is a relation. The domain, what values can x be? Well, x can be 2, -1, or 4. So, I mean, 2, -1, or 4, that's the order that the there, but maybe I wrote it in ascending order, -1, 2, 4. And I don't know if...
I think it's that. It's not the intercept, it's that. The domain and range.
It's this one?
Yeah.
It's going to make you write it in order. Is that what you remember?
Yeah.
So it may make you write it in order. It's set notation, that's what those parentheses mean. And they want you to write it in order. And then the range is 5, 3, and 10, but by writing that in order, we'll put 3, 5, and 10. Okay, what's the next one? You guys, probably some of you already figured it out. Figure out what the domain and the range is. And if a number's used more than once, you don't have to write it more than once. Just write it in order. So we'll say, write in order. Okay, so for x we have a 1, a 0, a 1, and a 3. So the x can be 0, 1, or 3. Just because we have the 1 listed twice doesn't mean we had to list it twice. That's the domain. And the range is what? Did you already figure that out? What's the range?
-11, 5, 6, 7.
All right. That is in order already. Okay, good job. All right. Now we're going to find out the definition of a function. Maybe you guys remember this. A relation in which each member of the domain corresponds to exactly one member of the range is called a function. And another way to put it is that a function's a relation in which no two ordered pairs have the same, they can't have the same first component and different second components. So, just looking back up here, was this relation a function? Do you see they have no repeated first components, so it is a function. It can't have the same first component and different second component, so it can't have any repeats. It can't have no repeated x's. With different y's. Okay? Alright, so this up here is a function. Yeah, it's sideways. This is a function. Is this one a function? Got 1, negative 11, and 1, 6. So this is not a function. It's still a relation, but it's not a function. And then you can do the next examples. So look for x repeated more than once with different y's. So are there any x's repeated here? No. So it doesn't matter that we have a 210 and a 410. That doesn't matter. It's still a function. So this is a function. We can have repeated y's with different x's. We just can't have the same x's with different y's. And we're going to get to this in a minute, but the way I like to do this is it's called the vertical line test. For functions. If you would graph these ordered pairs, so let's say 2 10s up here, this may not be to scale, okay? 2 10s here, negative 3 zeros here, 4 10 will be up here. That thing was in the way. And 3 7, say right here. Okay. So it's not to scale. Notice that you cannot, if you draw a vertical line, you can only draw one through one point. I don't know if you remember this vertical line test. And I like to use it on relations like this too. Because it's hard for me to remember, can there be 2 x's with different y's, or can there be 2 y's with different x's? So if I graph it and check out the vertical line test, since I can only go through one point with each vertical line, this means this is a function. If you went through 2 points, it wouldn't be. So what's the next one be? Well, it's got a 2 and a 10 and a 2 and a 0, so it's not a function. And if I just would graph the 210 and the 20. Here's 20, here's 210. You can see that you can draw a vertical line through 2 points. So it's not a function. So if you have trouble remembering that, you can graph these. Okay? All right, any questions? All right. All right, so, next example. Let's see. My notes are out of order, I think. No, this is the next page, right? You guys just printed this out. But my filled-in notes are out of order. I thought so, but okay. This example, you're going to determine whether each equation defines y is our dependent variable, as a function of x, the independent variable. And in this type of problem, you need to first solve for y. So here we are checking to see if these equations are functions. Are these equations functions? So before we were checking relations, just ordered pairs. Now we're going to check to see if equations are functions. In order to do that, we solve for y. So to solve x plus 2y equals 7, we want to get the 2y by itself, so we subtract x from both sides. So 2y equals negative x plus 7. Now you're going to divide by 2 to get the y by itself. So first get the term with y in it by itself on one side of the equation. And then since we're multiplying by 2, we're going to divide each term by 2. So I can either do divided by 2, divided by 2, divided by 2. And you get y equals negative 1/2 x plus 7/2. Or you could have divided both. So you can write this many different ways. You want to write, you can write it like that, or you can write it. We could have divided the whole. We could have wrote it as y equals negative x plus 7, all divided by 2. That's the same answer. If you want it in slope-intercept form, that's that way. This is acceptable too. I like it in slope-intercept form, but you could have divided the whole thing by 2. So you can separate and divide each term by 2, or you can divide the whole side by 2. You see? So that's the same. Those are the same answers. So these are both correct. Either this or this. Well, let's make a table and try to figure out when you substitute for x, is there any way that you'll get two values? When you pick numbers for x and put it in, say you pick 0, is there any way that you're going to get two numbers for y? So when I put in 0 here for x, I get 7 divided by 2. I just get 7/2. There's no way I can get two numbers. This is what we're checking to see. Can I get two numbers when I put in 1 for x? You get negative 1 plus 7 is 6. divided by 2 is 3. So you don't have to show every little step. 2, plugging in 2 for x. You get negative 2 plus 7, that's 5, divided by 2 is 5 halves. So do you see that there's no way, no matter what I pick for x, I won't get 2 y's. So we're not going to have the same x with 2 different y's, so it's a function. So when you have something like that, that's a function. You're probably going to understand it better once we do one that's not a function. Okay, the next example, solve for y. We just need to subtract our x squared. And they're not like terms, so you're going to get y equals either 16 minus x squared or negative x squared plus 16, either way. You have y equals 16 minus x squared. Make an xy table and see when I plug in numbers for x, will I can I get 2 numbers here? So if I put in a negative 1 for x, what do I get? I square the negative 1, I get 1. I get 16 minus 1 is 15. This is that parabola we just did. Similar. If I put in 0 for x, what do I get? 16. What if I put in 1 for x? I get 16 minus 1 squared is 16 minus 1 is 15. Okay, I have different x's in the same y, but that's okay. And if we did the vertical line test, we would see this is a downward facing parabola, like the one we drew on the previous page. And if we do the vertical line test on it, no matter where we go, we're only going to go through one point, so it's a function. So remember, you can use the vertical line test. You could have graphed these and seen that you could do the vertical line test. But on the test, I'm going to want you to solve for y and show it algebraically. But you can check your work, drawing a little sketch. So this is a function. And you're probably going to understand it better when we do this next example. Solve this for y. So, solve for the y squared. You get y squared equals 8 minus x squared. Now you have to use the square root property. This was from algebra. The square root property says that you can take the square root of both sides, but when you do that, you have to put a plus or minus in front of one side. So you take the square root of y squared, and you take this, and it's plus or minus the square root of 8 minus x squared. You have a plus or minus here. So when you take the square root of that, you get y, because the squared and the square root cancel each other out. But we need both the positive and the negative here. Why is that? Well, if you know that y squared equals 16, what can y be? Y can be 4 or negative 4. Because if we take a negative 4 and we square that, we get positive 16. So that's why we have to take do plus or minus here. So we have, so we can make another table. So here's our, here's solve for y. We get y equals plus or minus the square root of 8 minus x squared. Okay, so I'll just do an example. Let's do x equals 1. What do we get? You get a positive 8 minus 1. 8 minus 1 is 7. So it's a positive square root of 7. And then the negative square root of 7. So we get two answers for y. Then that's not a function. Now if we drew this, I'm trying to decide which way it would go. I can show you on the calculator. For this function, for this relation, it's a relation, not a function. I can do positive square root of 8 minus x squared and that's what it looks like. Okay, 8 minus x squared. Looks like an ellipse or something. Okay. And that's only half of it. The other half is negative square root of 8 minus x squared. There's the other half. And when we do the vertical line test, we go through 2 points, except at the ends. All right? All right? So there you are. There it is graphed. So I'll draw, I'll sketch that. So that looks like this. This. Kind of. And then your vertical line test fails. It's not a function. But you've got to remember from algebra the square root property. And the fact that we can have two numbers. When we take the square root of both sides, we have to add that plus or minus. Okay? All right. Just, you guys doing all right? Do you need a break? We're doing all right? Need to get up and stretch? All right, we'll keep going. Function notation. The special notation f parentheses x close parentheses. When we read, we say f of x represents the value of the function at the number x. So f of x equals x squared minus 10x minus 3. Evaluate each of the following. So we're going to find f of 4. So what you do, and of course it's easy when it's a little positive number like this, but you're going to, everywhere you have an x, you're going to put parentheses, minus 3. And then you're going to fill in what x is 4. So everywhere we had an x, we put a set of parentheses. That way we won't make any sign errors. And then we have to follow the correct order of operations. We need to do our exponents first, and then multiply, and then we do our subtraction. So doing the exponent, 4 squared is 16. 10 times 4 is 40. Minus 3. Okay. And then 16 minus 40 is, and you can even do that on the calculator, but remember it's a positive 16 and a negative 40 and a negative 3. I mean, you can rewrite this as 16 plus negative 40 plus a negative 3, or however you want to do it. You can add these two first. The order of adding doesn't matter. You can switch the order. If you remember that, this is minus 43 plus 16. And you can, of course, use your calculator at this point, but we're going to subtract and keep the sign of a larger number. So if I was just going to do it here, I would do negative 43. Actually, 43 minus 16 is 4, 7, 27, negative 27. And then I would check it. Make sure it didn't make a silly, stupid mistake or something. So you could even do 4 squared minus 10 times 4 minus 3. And it's negative 27. We didn't make any mistakes. But you don't have to show all those steps. You could show this. I want to see this, and then you could show the answer. You could just show 1, 2, 3 steps instead of 5. But if you want, you can show more. All right, now this is going to get harder. I can't type this in the calculator. What am I going to do? Okay, so now instead of replacing x with a number, a simple little number there, I'm going to replace it with x plus 2. So f of x plus 2 equals, and I have to leave more room, blank squared minus 10 times blank minus 3. Everywhere I have to put that x plus 2 in. Okay, so now you got to remember how to square a binomial. Equals x plus 2 times x plus 2. So you can do FOIL, you can do distributing. FOIL is first is x times x, it's x squared. Outer is 2 times x, and that's positive. Inner, so it's first, outer, inner, last, FOIL. Inner is 2x, and they're all positive. And 2 times 2 is 4. Then combine your like terms. You get x squared plus 4x plus 4. Unless you have it memorized how to do that. You can do that off to the side somewhere. This equals x squared plus 4x plus 4. And then I'm going to distribute the negative 10. Minus 10x minus 20 minus 3. Then you're going to combine your like terms. There's only one x squared term, so that stays there. You have a 4x minus a 10x. 4 minus 10 is negative 6x. Then you have a 4 and a negative 20 and a negative 23. And so you can, if you want, you can take your calculator and do 4 minus 20 minus 3. If you want. And that's negative 19. So here's your answer. Okay? Any questions on that one? Got it? All right. All right, and then I'm running out of room here. F of negative x. So that means everywhere we have an x, just substitute negative x. So I guess I'll put in f of negative x equals, we've got parentheses x squared minus 10 times x minus 3. So everywhere I have the open parentheses, I'm going to put in a negative x. That's my variable, replacing everywhere I had x with x, negative x. When you take negative x and square it, you get negative x squared or positive x squared. All right. When you take negative 10 times negative x, you get minus 10x or positive 10x? Positive. A negative times a negative is a positive.
You still have x squared?
And then you have minus 3. What?
You still have x squared?
Yeah? Did I? That's the answer. X squared plus 10x minus 3. What did I?
It would just be x.
Where this is a squared. Can you see the squared?
Yeah, I'm just saying if you squared negative x, would it not be x just positive x?
No.
Hey,
Okay. No. You get x squared. If you square negative x, you get x squared. If you square x, you get x squared.
okay.
It's negative x times negative x. And the negatives make a positive, and x times x is x squared. Okay. So if you forget some of that, you can do that. Yeah, review your rules of exponents if you struggle with that. All right, and the graph of a function is the graph of its ordered pairs. Okay, and here's my favorite test for functions that I was using before I got to this. The vertical line test for functions is if any vertical line intersects the graph in more than one point, the graph does not define y as a function of x. So we're going to use the vertical line test to test if y is a function of x. So no matter where on here that I draw a vertical line, can I go through more than one point? No. So this is a function. But on B, what happens? If I can draw a vertical line anywhere and go through 2 points, it's not a function. It doesn't matter that I can draw a line right here and only go through 1 point. Doesn't matter that I can draw a tangent line there to the circle. If I can draw a line through it, the relation anywhere and get 2 points, it's not a function. Okay, so that's the vertical line test. Right? Any questions on any of that? Your vertical line test, right? Okay. All right, now we're gonna do some of this. Which I have that. Okay. Well, we've got how many more pages in section 1? 1, 2. We only have 2 more pages in section 1.2. Okay, so this is an important type of example because you're gonna need to be able to do this on your homework and on your test and everything. So we're gonna use the given graph to answer each question. So you need to understand function notation. So whatever's inside of these parentheses, that is your x. Here's the function, y equals h of x. Find h of -6. So when x is -6, what is y? That's, you know, when x is -6, so, oh, I gotta go this way. So here's -6. Here's where x is -6, so the function at this point. So what's the value of y? 5. So here's what you're asking yourself. When x is -6, what is y? That's what I asked myself to find that. When I had to go to -6 on x and find where x equals -6 intersected the function, then I had to go over to see what value that was and why. Or I could just look. I don't have to draw all those little dashed lines. Okay? Does that make sense? So find h of 4 then. Can you find h of 4?
-3.
Correct. Very good. So here's 4 for x. You go down, it's -3. All right, what's h of 20? So when x is 20, what's y?
Probably -3.
Yep. Well, see, this arrow means it continues as it was, so it's constant all the way out. So at 20, it's going to be -3. So the part in the parentheses is our x, and this is our y. But it's a y when x is 20, you know, specific y. Okay. Find h of 0. What? Right. That's right. So just keep this straight. All right, for what values of x is h of x equal to -2? So this is y. So the other way to write that is when y is -2, what is x? And it can be more than one answer. Okay? So when y is -2,
3.
y is -2, you do get x equals 3. It doesn't hit the graph more than one. X equals 3, not -3. Oh, there you go. So x equals 3. For what values of x is h of x equal to 2. So when y equals 2, what's x?
-1.
Negative 1. So you want to write x as negative 1. So on these up here, when h of -6, that equals 5. But you can't just say that this equals -1, it's x equals -1, and x equals 3. Okay. All right. So that's function notation, practicing questions for function notation. Then we find the domain and range of each function, and we want to write the answer in interval notation. The x-intercepts and or y-intercepts, and write those as ordered pairs, and find the missing function values. So this is very similar to the homework that's due to it.
You want the homework in interval notation?
Yes. I'm going to bring a chair over. It's hard to stand. Okay. So, all right. To find the domain and range of each function. I already read that. Okay. So, domain. Now remember, if you got a figure and it stops and doesn't have a closed circle, it means it keeps going. Okay. So there should be arrows here. All right, to find the domain, that is the values that x can be. You kind of think about projecting this to the x-axis. Project the graph to the x-axis. And remember that this keeps going up at an angle, so you're going to have all that. So what values can x be? Where's my red lines touching the x-axis? And this keeps going to infinity at an angle, and so does this. So the domain x goes from minus infinity to positive infinity. Now if you are typing this up in a Word document to put it in the Dropbox, you can simply type in minus infinity, comma, infinity. On the test, I'm going to want you to put this infinity symbol. This is like kind of like a sideways 8. Yeah.
I am
If you
definitely
want,
tired, but I was thinking interval notation was like negative infinity is less than x is less
No,
than
this is-
infinity.
okay.
And set notation is that. Or am I wrong?
Now, this is interval notation.
What's the one with the less than greater than?
X such that minus infinity less than x less than infinity. That's set notation.
That's set notation. Okay, so I have practice. Okay.
This is this set symbol. This is set notation.
Good.
This is interval notation. Okay? All right, and range. Okay, so you're going to project the function to the y-axis. You can project it here too if you want, but can you see that this is a parabola, and it actually, if the vertex looks like it's right at a point, then it is, okay. With a parabola, it actually is takes on this value of minus 3, 2. This is the vertex, is minus 3, negative 2. Okay? So the range is minus 3, and it includes the minus 3, so we use a square bracket. And then it goes up to positive infinity because this keeps going. And you have to put a square bracket here because we're including the negative 3. And then infinity is not an actual number, so we never include it, so we use a regular parenthesis. So you don't need to write this in set notation. Okay? So that's how you can find the domain and range. Does that make sense? All right, and then the x-intercept, well, and just approximate it. There's 2 x-intercepts.
Negative 3.75.
Yeah, you can do that. Negative 3.8 maybe, or 3.7. It doesn't matter. Comma 0, comma, and the other x-intercept.
I said negative quarter.
Negative 0.2 or something, or you said 0.4. That's fine. Comma 0. So that's just, we can't, it's okay that you can't read it as crossing at a point, but okay. So that's the x-intercept. Y-intercept looks like it crosses right at that. So what's the y-intercept? 0, comma 1. Okay, and then what's f of negative 3? So when x is negative 3, what's y?
Negative 2.
Right. Okay, and then for what values of x is f of x equal to negative 2? And that's y. What values of x? So f of x equal to negative 2. So when y is negative 2,
Negative 3, negative 1.
when y is negative 2, what? Yes. Right. I started going to negative 2 on x, I have to say. Yeah. When y is negative 2, x can be negative 1 and negative 3. Or you could put in this blank, negative 1, negative 3 with a comma, because I do have a blank there. So that's fine. Okay, and the next one, domain and range. So project to the x-axis. So, and what does this open circle mean?
Not good. Well, anything but. Right?
Yeah, it means it doesn't include the negative 2. And it doesn't include the negative 4 on the y-axis. So it doesn't include the negative 2. And then this goes out to positive infinity. So that's infinity. Now the other thing you need to remember is when you're doing interval notation, smallest number, largest number, left to right on the graph. So don't tell me that the range up here was infinity, comma, negative 3. You're going to be counted wrong in my math lab when you do that. Okay, and then the range is what? So you can
Negative 4, infinity.
project this. And this, you assume this goes up at an angle and keeps going up. So it is -4. We start with -4 and go to infinity on the y. Okay, so this is y. All right, the x-intercepts. Wow, that's hard to tell, isn't it?
Yeah.
Maybe you could take a kind of approximate with this. Something like that. I don't know. Here, we'll continue this line. Hopefully I'm not going to, I don't think I asked you something that goes off the page like this. So it's somewhere out here. So I'm going to say that because is 10. 10, 0. I don't think any of yours is going to go off the page like that.
Good.
All right. And then what's f of -1? Oh, we didn't do the y-intercept. Oh, that
-2.5.
-2.5. Yeah. The y-intercept is 0. Whoops. I almost put -2.5 first. -2.5 or something like that. It's close to that. You just have to get close on your answers. All right. Now f of -1. So when x is -1, x is -1. What is y? -3. For what values of x is f of x equal to -2? So when y, so that's what I say, when y is -2, what is x? That's what I asked. So I really think that in my head. Or you can write it down. When y is -2, what is x? Is about 2. So that's 2. Okay, so that's just like the, any questions on that? That's just like your homework. All right, and then a word problem example. All right, and then we'll be done with this section. So, to go, please. So, these graphs show that more Americans are ordering their food to go instead of dining inside restaurants. A quadratic function models the average number of meals per person that Americans ordered for takeout. And a linear function models the average number of meals ordered for eating in a restaurant. Any function that has x squared as its highest power, we call it a quadratic function. Any function that just has an x as its highest power is a linear function, a straight line. In each model, x represents the number of years after 1984. Use the graphs for the displayed equations to solve the following problem. Okay, so use the equation for the function t to find and interpret t of 18. How is this shown on the graph of t? So t equals 18. So we're not even going to use this r of x function. They're just asking us about, oh, well, we will later. Never mind. T, we're asking about the takeout. Here's the equation for takeout. I'm going to write it bigger. T of x equals minus 0.125 x squared plus 5.25. That is a plus sign there. You might have trouble reading. Times x plus 72. Yeah, 72. Okay, so that's the intercept. It crosses at 72. So what is t of 18? This is where you're going to use your calculator to find this. We don't expect you, but it's negative 0.125, and everywhere we have an x, we're going to put an 18. So it said to use the equation in the first part. That's what I'm doing. So you're going to type that in your calculator. T of 18. Okay, so negative 0.125 times 18 squared. The calculator lets you just flip the squared thing here. Plus, it lets you get away without the parentheses. 5.25 times 18 plus 72. And that's 126. So using the equation, we get t of 18, what? Equals 126. So this equals 126. How is this shown on the graph of t? Well, if you go to 18 on the number of years after 1984, the calculator away, and you go up and where you hit t of x, then you go across, it's kind of really close to where this thing is there. That's 126. And looking at that from the picture, I would just guess that t of 18 from the picture is approximately 130. I wouldn't be able to tell that it was 126. That's supposed to be approximate. Okay, 130. So, and what does t of 18 mean? 18 years after 1984. So 1984 plus 18 is the year 2002. So in the year 2002, so I'm just saying part A as, what is this telling you? In the year 2002, approximately 126 meals were to go, right? Average number of meals per person. Approximately an average of 126 meals were taken to go. So that's what that means. Okay, use the equation for the function r to find and interpret r of 20. So this is interpreting T of 18. What I wrote out in words is interpreting T of 18. What's that really mean? That's important for you to be able to do that for a word problem. And so R of 20, here's the equation for R. I'll write it here. R of X is negative 0.6X plus 94. That's the number of meals that they ate in a restaurant. We're going to put in 20 for X. Negative 0.6 times 20 plus 94. We'll just do that on our calculator. Times 20 plus 94. And that's 82. Okay, so what does that mean? 20 would be 2004. So that means in the year 2004, the average number of meals eaten in restaurants of meals eaten in restaurants. Or, I'm saying it like Yoda here, back. Restaurant was 82. I had already started writing it. Okay. Switch around your stuff in here, you can be like Yoda. Okay, it's okay in a math class to talk like Yoda. It's okay. From Star Wars. Okay. I do it all the time, don't worry. Okay. All right, and that is the end of section 1.2. And 1.3 is 4 pages. So, where's my schedule? Next time, I'm going to stop the recording.